Hi. My presentation, Schematron, more useful than you'd thought. And basically, there's two areas I like to work in, not surprisingly, A, XML, and B, also the semantic web. And one of my most favourite aspects of the XML world is Schematron. And we're going to take a quick look at what Schematron is. How many people in the room here know of Schematron? That's brilliant. And how many people have actually used it recently? Brilliant. So, fortunately, we won't be spending too much time on actually looking at Schematron, because by the look of it, most of you have already made use of it. Schematron has been around for quite some time, almost as long as XML itself, and its primary custom validation is its area, and it sort of covers the things that XML Schema 1.0 didn't do. So from that perspective, it's quite a flexible thing, and it's a perfect fit for the technology that it's used in, because it is XML, it uses XPath, and it's been, the reference implementation was created using XSLT. So for the community of XML developers, it fits in perfectly. And the nice thing about the reference implementation is that, to my mind, it's an excellent template or example about how you can write really good extensible style sheets. And one particular aspect of that, when Schematron became rolled into one of the ISO standards, they introduced the schema validation and report language. Up until that point, Schematron had only output a textual line-based report, and SVRL introduced an actual XML structure to that, and that is one of the aspects that we'll see we make use of later on. So just as a quick sort of recap, remind ourselves what Schematron looks like. We have our document structure, we have the concept of patterns that contain rules. Those rules have a context within for the particular document you're testing. And in this example here, we look at assertions where we define the context is the root of the document, and our assertion says that we must test to see that there is a atom feed attribute in this document, and if it doesn't exist, then we generate an error that says that the document root must actually be a feed element. The problem we're going to look at is mapping data to RDF. Now, a lot of work has been done, especially by the W3C, in coming up with various ways of mapping relational data to RDF. There's a basic mapping recommendation called RDB to RDF, and that basically takes row data from your relational model, and each row becomes a triple in your RDF graph. Each column name is used directly as the predicate for your triples, and the actual cell value is the object. It's quick and dirty, it can get you started, but it's not actually that useful. That's why they came up with R2RML, relational to RDF mapping language, and that's a far more useful technology, because it actually allows you to identify a target vocabulary that you want to work with in your mapping. And various people have come up with tools for, in effect, allowing you to have a sparkle layer that sits on top of your relational database. So all your relational data can actually appear like a graph. But what about XML? Not a lot of work has been done on that same journey from XML to RDF. So what we're going to do now is sketch out a solution for this using Schematron. So in our examples, we're going to use the atom feed syndication format. There's a very simple example. There's no entries in there. It's just the wrapper for the feed. And we're going to look at the atomal vocabulary, which somebody came up with a mapping of atom into RDF. And it's a very good example to look at, actually, for a lot of reasons, because given that a feed document on atom feed has a certain amount of structure in it, the mapping that's been designed for Atom L actually looks at a lot of the problems you have in mapping structure into RDF, because in RDF there's no concept of hierarchy. You have to actually do that explicitly yourself. The really important aspect we've got here is in an ISO rule, we've had a quick look at the assertion, but the important one in our case is the report, because what a report does, it will, for that atom title element, it will test to see that it exists, and rather than actually output, what it will actually do is output a message that says that this element appeared in the document. And what I'm using here is the message says that the ID of this feed has, or this document with this ID, has a title of example feed, and we've used the value of elements in the report to actually extract the text value from the ID and the text value from the title. So in effect we've constructed a sentence about the thing that we're testing here, the title element. And to look at that, expand on that point, there's our feed document again, there's the sentence I've created, and here is an RDF triple that basically says, implements what that statement makes. So we've taken the subject for our triple from the ID of the feed document, we've taken the predicate from the title element, and we've taken the object from the text value of the title. So what we're actually using is using the report mechanism to write triples instead of ordinary statements. XML scissor lift is a framework that I've been working on to actually make a reality of this. And the concept of schema lifting and lowering is something, it's a terms used by the semantic web community, where they talk about taking an XML schema and actually mapping its concepts up into an RDF vocabulary or ontology. And what I've done with SysLift is made use of existing technologies. We're talking about Schematron. The web application description language, I've taken some features from that and rolled that into the language, the mapping language that I've created. We use aspects of the XML pipeline language, XProc, and the whole processing framework is run through XProc. We use URI templates and, albeit little known XML representation of RDF called triples in XML, or tricks, its short name, which was developed by some people at HP Labs. We're going to look at a basic mapping. We have a lift document, because we're dealing with the lifting part of the process in this presentation. Sorry. We can do certain things. We can obviously put in namespaces, and we give names to these things, and we can declare variables in the root of our document so they have global scope. We can reuse that feed URI variable, as we'll see shortly. We reuse the concept of the pattern and the rule, but instead of the report, the lift document actually embeds, you could think of it almost like a template for the triple using the tricks grammar. But we introduce, we use the context to set where this rule is going to work, and then we have our match attribute that says what the element we're looking for. And we create the subject URI from the select expression, which is getting the feed variable, or URI for the feed. Predicate, we're putting in both literally and the object as well, because we're going to say that this feed element represents an instance of the feed class in the ontology. And there's another rule down here, basically does the same thing, but we have the example of creating plain literals for the object of our predicate, which is the title in this case, and we take that from the type element in this context. And the output creates the tricks output. So we have a graph, and the triples are obviously an exact replica of what was in the lift document, except for obviously the places where the select statements have been used create or insert the values into the triples. Now in Schematron there are three processing phases. There's an include phase where you deal with external dependencies, an expand phase where Schematron deals with things like abstract rules and patterns, and then the compilation phase. What SciSLift introduces is a translate phase, which we'll look at in a moment, and of course finally we have the execution phase where we apply these mappings to our source XML documents to generate our RDF graph. So here's a fragment of a mapping. We've got our rule, and what happens in the translation phase, the rule is converted to an ISO Schematron rule. The triple element becomes a report. So all those parts can be processed as normal by the Schematron transforms, and we just explicitly ensure that the subject, predicate, and object components are in their own namespace, and they get effectively ignored or not touched by the transformation process until the compilation phase. Look at some more advanced mapping features of SciSLift. We've seen that we can use select attributes with XPath expressions to evaluate in a particular context, but they can tend to lead to some sort of complicated concatenations. So I'm reusing URI templates where we define placeholders in the URI to put in variables, and these parameter elements are taken from WADL, the Web Application Description Language, where you actually define those parameters and where the values come from within the source document. You reuse the concept of abstract patterns so that you can make or reuse sections of your mapping document throughout. You declare a pattern as being abstract, give it an ID, and then that's reused elsewhere in the document, and you can pass in parameters into that pattern to give it the context in which you want to use it. Abstract rules as well. Defined in a similar way, and where they're used for a given context, you can say that that rule extends this one. So in the case of link elements, they're used in both the feed and the entry elements, so you can save yourself some time in the creation. And these are all part and parcel of Schematron features, but that have been, in effect, mapped into this new usage. Dealing with structure, I mentioned structure earlier. One of the issues you have, which we take for granted in XML, is that things like attributes, their relationship to the element that they have is implicit, whereas in RDF you actually have no concept of hierarchy, so you have to do that explicitly, and that's where blank nodes tend to be used in RDF, where you don't actually need to give something a particular known identifier. So what you see here is this first triple, which is identifying that in this particular context there is a link, and we give it in effect an anonymous ID, and then in the following triple that becomes the subject, so that we're actually saying then we have a link and we say that this thing that is linked is of that particular type link. So you can actually start dealing with structure. And again, I recommend if you want to get a good idea of how those concepts are shared between or have to be done in XML, look at the atom-out ontology and you'll see some of the contortions you have to go through to represent that information in RDF. We use the report element for generating our triples in Schematron, or within the world of Schematron. So that leaves us free to deal with data integrity issues by using the assertions. So in this particular rule fragment, doing a mapping of the title as we've seen before, but we can say that that's only going to happen if this assertion is true. So we can do checking of our data during conversion from XML to RDF. We'll take a quick look at actually how, and I say quick because there isn't actually an awful lot to it really. The XSLT implementation accommodates extension. It's very well written and thought out. As I said, that's initially how SVRL was so easily worked into the transforms. The XSLT import mechanism, again, is very useful because we take the ISO Schematron's skeleton. I use the XSLT2 implementation of those transforms that runs nicely in Saxon. So I import that into my own style sheet, and then I can create new templates that override the existing behaviours. And the key ones to make note of are the process root and process report templates, because the report one allows you to deal with the wrapper for the output that you want to generate using Schematron. And in this case, because we're using reports, process report allows you, that's your jump off point for extending how reports work. But there are quite a few other ones, and I've listed out 4 other useful templates, which are pattern, rule, assert and value of. But in addition to that, there are other extension points, because as we mentioned previously, we have the 3 phases in Schematron. So if, for example, you wanted to introduce new types of dependencies, you can do that in the include step. If you've got particular features you want to add to the way abstract rules or patterns are dealt with, that can happen in the expand, and we've just talked about compiled phase. Now, there are other mapping options. I said a lot of work has been done. I imagine many people have written bespoke XSLT to convert RDF XML into or XML into RDF XML, for example. And people write XQuery to do this sort of thing as well, and that's all well and good. Nothing wrong with that, I might add. There is another technology that the W3C have worked on with a horrendous name, Semantic Annotations for WSDL and XML Schema. And the acronym is even worse, SORSDL, is the way of pronouncing it, I think. And what that does is allow you to put annotations on XML schemas. Funnily enough, it doesn't use the annotation mechanism in XML schema to do it, but what we're doing here with this model reference attribute, we're basically saying, in this example, we have our feed element, and that we give it a type, complex type, which is feed type. And in this model reference, we're saying that that maps to the feed class in the XML vocabulary. It's very straightforward. It also allows you to identify external transforms, for example, to implement some of the more complicated patterns that you can't do with straightforward references like this. But there are a couple of downsides. One, you need an XML schema in the first place, and not everybody has one or wants to go to the trouble of creating one just to map some XML to RDF. And secondly, you've got to put annotations in potentially somebody else's schema, which tends to be a drawback for some people, because it means you, when updates to the schema arrive, you've got to update all your annotations. So that's one of the driving factors for coming up with a completely independent mechanism for doing the mapping of XML to RDF, which is separate from any existing or working on existing schemas. So the conclusions that I've come to, as I've said, the implementation is very extensible. I really do thoroughly recommend people look at it closely because it is very good. Overriding basic behaviour is very simple, both in Schematron and with XSLT as well. It's a very useful aspect, the import instruction in XSLT. There are other reporting tasks that Schematron can do. A long time ago, I did some other work where I introduced Schematron for validation purposes, but the customer wanted Excel spreadsheet output. So I did, in effect, an extension of Schematron then along these lines because it's another line, in effect, line-based output spreadsheet. You have a container and then you've got lots of rows with information in. So you could use this mechanism for getting Schematron to generate Excel spreadsheets, for example. One of the things that made my life easier in creating Scissor-Lift was reusing existing technologies, and it also hopefully will make other people who use this life easier because there are common patterns in there. There are URI templates, there is the Schematron principles, and aspects of things like, as you saw, the web application description language. In Scissor-Lift, I've actually used it in 3 projects in the work that I do, and it's been very useful. I even got onto a Skype session with somebody in the US, and within an hour we've got his data starting to be converted from XML over to RDF. So it's a nice, simple, straightforward, I believe, mechanism. Now I do have some future work to do. One of the things, and that's another aspect of Schematron, are phases. I don't know whether, does anybody use phases in there? Good. They allow you to actually subdivide your schema into different components that you can run either all together or individually. And it would be nice to implement that with Scissor-Lift so that you can break your mapping into sections, because especially if you've got large amounts of data that you want to work on, if you can break that down, you don't have to spend ages waiting for processing to go on. Just as a hint, running on my Mac there, I can get somewhere in the region of 2 million triples an hour generated, or documents processed into triples, I should say, using this mechanism. So it's quite quick. Syntactic shortcuts. One of the things that you may notice very quickly when you're using Scissor-Lift, if you use Scissor-Lift, is that you have to keep on writing out the subject part of the triple every time. And I've given that some thought because, for example, R2RMA deals with that quite neatly in the way that its vocabulary works. But what I didn't want to end up doing is, in effect, reinventing RDF XML. So I've left it as simple as I can for the time being. I may introduce something a bit more helpful in that respect. Name graphs would be useful. The tricks grammar has a concept of a URI for the graph, so that should be relatively straightforward to integrate. Validation of XPath expressions. I don't know if anybody's ever tried this. A neat trick you can do in XProp, where you can get it to evaluate XPath expressions in documents to actually check. They don't need to actually resolve to anything, to any particular node, but what you can do is get XProp to actually evaluate that path expression, so you can do validation on things. I'll hopefully introduce that. And there's a GitHub project called Scissor-Lift that you can have a look at, but I do apologise, there's no documentation yet. That will come. For the time being, I've been concentrating on the day job. And that's Schematron. And I might even make a badge out of that. That's it, thank you very much.
We have time for questions.
You're using Schematron as a transformation language rather than a validation language, which is an innovation as far as I'm concerned. What merits does Schematron have as a transformation language, that make it suitable for this task? Would you recommend using it as a transformation language for other tasks in preference to using raw XSLT?
I think only in this case, because I mean, what originally struck my mind was because the report does a job of writing sentences out that you put information into. It was one of those sort of light bulb moments where you think, oh wow, I can do triples with this. I'll follow that path. And knowing that I'd done a similar thing with Schematron doing other line-based outputs, it seemed like a way of abstracting away the underlying sort of processing mechanism, which is XSLT, and just come up with a domain-specific language for purely dealing with a context and extracting it. It's kind of like it's the same question you might have with XProc and XSLT. Where do you draw the line between you can do just enough XProc and you reach a point where you think, oh gosh, I could have actually done that in XSLT, couldn't I? And you invariably realise you've gone past the line when you've gone too far. So in this particular case, having the triple, and I wanted something that was very XML orientated for people coming from an XML background to generate RDF. And I didn't want the distraction of having to think about modes and generating templates. And I wanted to just try and keep it as simple as possible. So there's no real, I guess, major win in that respect, other than being able to introduce other patterns that like the URI parameters, URI template, sorry. Just using things like that to make the process a little bit more, less about code and more about being declarative, I guess.
I mean, you could ask the same question about Schematron itself, because there's nothing Schematron does in error checking that you couldn't do in pure XSLT, is there? So I guess that's the same.
Yeah, Schematron as a validation language seems, to add value on top of XSLT in an obvious way. Where it's less clear to me here.
So is there a reason that you particularly chose Trix, or was it just because it was there and that was a suitable presentation?
I didn't want to resurrect the zombie of RDF XML.
Okay.
That was one of the main reasons. And again, I wanted to keep it very triple orientated, to make people think about triples and not get embroiled in all the syntactic shortcuts that makes RDF XML such a pain in the neck to process. So I think that was the main reason. And also, it's quite explicit in the way it deals with, you're creating a URI, or you're creating a plain literal, or you're creating a type literal. So it's very, what's the word? Obvious what you're doing with it. Yeah, that's the word I'm looking for.
Could you give us a bit of detail on how you tested that? You mentioned tested, you got some document processing. What did you test with that? In database, outside database?
I do all my development in Oxygen. That's my preferred development environment for this sort of thing. But, for example, I've run the transform, because the output of the Schematron processing mechanism is an XSLT. I've run those in MarkLogic. So I've had a database of XML documents, and I've had an RDF database, and I've pumped all the documents out of the document database through the transforms and into the RDF database. And there, just on a simple laptop, that was pushing somewhere in the order of 2 million documents an hour.
So your transformation process and validation process was in between, outside the database, in between the two?
No, that was actually running or executed in MarkLogic as through xQuery. Yeah.
Any more questions?
Excellent. Okay. Thank you, Philip.